On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, this is an introduction to the product rule for differentiation. We're going to find the derivative of this function two different ways to serve as an introduction, but ultimately, sometimes you cannot find the derivative two different ways, and you'll have examples such as these two here, where the only way to find the derivative of this here or this piece here is to use what's called the product rule for differentiation. But for this introductory example, we can do this two different ways. Let's find y prime. What I'm going to do first is I'm just going to multiply these two binomials together. 2x squared times x is 2x cubed. 2x squared times 4 is 8x squared. Negative 3 times x, negative 3x. And negative 3 times 4 is negative 12. Now we can find this derivative using our basic differentiation rules. 3 times 2 is 6. X squared, remember to subtract 1 from your exponent. 2 times 8 gives us a 16. That's going to be x to the first because again we're subtracting 1 from our exponent. The derivative of negative 3x, pull the 1 down, times the negative 3 is minus 3. This becomes x to the 0, which we do not need because that's just 1. And then finally the derivative of a constant is 0. So here is our derivative. But the technique we used here was a little bit of algebra first. Then we did the calculus. Same exact function. Let me show you what the product rule does. Technically what we have here is we have this piece here. This is some function. I'm going to call it f, and it's getting multiplied by another function, g. I'm calling them f and g because that's probably what your book uses. Some books use u and v, but I'm going to use f and g. And we are multiplying these two functions, and we want to find the derivative, because it says find y prime. We're going to get this same answer, and here's the product rule. Y prime, using these function notations here, is going to be equal to the following. We take f, and we multiply it by g prime, and then we take g and we multiply it by f prime, and then we add these two pieces together. It does not matter what order you do these, since we are multiplying these, and then we're adding them together. But what is important is the following. When I say f g prime, I'm really going to leave one function alone, in this case f, and then I'm going to multiply it by the derivative of g. That's what f g prime means. And then I'm going to leave the g function alone, and I'm going to multiply it by the derivative of f. Let's do that, and let's see if we get the same answer here. So therefore, y prime is equal to, take f, let's leave it alone. So we have 2x squared minus 3, and let's multiply this by g prime. So taking our g function up here, the derivative of x plus 4 is going to be simply 1 in this case because the derivative of x is 1, the derivative of 4 is 0. So we have just 1 plus 0. Plus, let's bring that plus down. Now let's leave the g function alone, g, so that's x plus 4, and let's multiply it by f prime, the derivative of f. The derivative of 2x squared minus 3 is going to be 4x, and that's going to be it for that one. Again, using our basic differentiation rules there, pull the 2 down, multiply it by 2, we have 4x to the first now when we subtract exponents, and the derivative of a constant is 0. So now let's clean this up and let's see if it matches what we have over here. Taking this 1 and multiplying it by this binomial does not change anything. So we have 2x squared minus 3. Taking this 4x and distributing here, we get plus 4x squared, and then plus a 16x when we distribute 4x times that 4. So plus 16x. Combining like terms and cleaning this up, 2x squared plus 4x squared is 6x squared plus the 16x minus the 3. And as you can see here, we are getting the exact same answer. Now, one would think, I'd rather do it like this every single time. Sure, you can do that when you have a polynomial times a polynomial, but when we start having other types of functions, sine of x times cosine of x, there's no way that we can multiply these together to make it any easier to differentiate. The product rule is required because we are taking a function times another function. The same thing over here when we have e to the x times this stuff. If you distribute it here, it's not going to make it any easier to differentiate. Hence, these are just two of many examples of where the product rule is absolutely required in order for you to find the derivative. We will do these two examples in a future video. But for now, I did want to give you an introduction to the product rule. This is the product rule right here. And I wanted to show you how we can get the same answer. In some cases you can, especially when you're dealing with polynomials times polynomials. But those other two examples will come in a future video, and that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.